logs have the same base and they are being added, the arguments can be multiplied. For example, log base 4 of 2 plus log base 4 of 5 equals log base 4 2 times 5, or log base 4 of 10. When logs have the same base and they are being subtracted, the arguments can be divided. For example, log base 4 of 2 minus log base 4 of 5 equals log base 4 2 divided by 5. When the argument of the log has an exponent, that exponent can be moved in front of the log as a coefficient. For example, when you have log base 5 of 5 squared, it is the same thing as writing 2 log base 5 of 5.
When the argument of a log has an exponent, and the base of the argument and the base of the log are equal, then the log's base and the base of the argument will cancel, leaving the exponent's base equal to x.
For example, when you have log base 7 of 7 to the 4th power, the log is equal to 4.
When an exponential has a logarithmic function in its exponent with the same base, you can use this property. Since exponents and logs with the same base and arguments are inverses of each other, a to the power of log a would cancel out, leaving the argument of the log equal to x.
For example, when you have 6 to the power of log base 6 to the 3rd, the exponent is equal to 3. When a log is difficult to solve with its current base and argument, you can change the base of the current base a and the argument x to have a common base of b by dividing the new log base b of x by log base b of the original base a. For example, log base 4 of 5 can be changed to have a common base of 3 by dividing log base 3 of 5 by log base 3 of 4. When multiplying logs that have an argument b and base b equal in value, the values cancel, leaving the log base a of c. For example, when you have log base 4 of 5 times log base 5 of 6, the 5's cancel, leaving log base 4 of 6.
When the base of the log has an exponent, the exponent's reciprocal can become the coefficient of the log. For example, log base 7 to the 6th power of 9 equals 1/6 log base 7 of 9.
To write this problem as a single log, first you would have to move the coefficients back to the powers of the arguments. So you would take the coefficient of 3 and move it back as an exponent of the argument x, and you would take the coefficient of 4 and move it back as the exponent of the argument x plus 3. Then you would divide out the arguments of the subtracted terms. So you would take x and divide it by x plus 3. Finally, you would multiply the arguments of the terms that are being added. Therefore, you would bring the argument y up to the numerator of log base 2 of x to the 3rd. To expand this logarithm, first you would undo the product property of the numerator by expanding it using addition. Then you would expand the denominator by undoing the quotient property out to subtraction. Finally, you would take the exponents of the arguments and move them to the front as coefficients of the log.
In this problem, we will first combine the log base 2732 with the log base 2714 using the logarithmic product property because they have the same bases. This will result in log base 278. You can rewrite this into log base 3 cubed 2 cubed. The exponent of 3 in the base will cancel with the exponent of 3 in the argument, simplifying the log into just log base 3, 2. We can also rewrite the log base 2, 9 into into log base 2 3 squared and move the exponent of 2 into the front. Our simplified expression is now log base 3 2 times 2 log base 2 3. The 3 and the base of the first log will cancel with the 3 and the argument of the second log, leaving you with just 2 log base 2 2. Since log base 2 2 is just 1, the log simplifies into 2. To simplify this log, first you will combine the natural log of x squared minus 9 with the natural log of x plus 3 using the logarithmic quotient property. Then you can factor out x squared minus 9 into x plus 3 and x minus 3. The x plus 3 in the numerator and the denominator will cancel, leaving you with the expression natural log of x minus 3. In this problem, the first step will be to combine the log base 7x and the log base 7y using the logarithmic product property so that it becomes one log base 7xy. Then you can move the 1/2 before the log to the exponent of the argument. Since they have the same base, you can then combine log base 7xy to the power of 1/2 with log base 7z cubed using the logarithmic quotient property, and you will end up with log base 7xy to the power of 1/2 divided by z cubed.
In order to evaluate this problem, first you must rewrite parts of the log so that we can use the properties. You can start by making the logs have a common base. The argument of 1/3 in the first log can be rewritten as 3 to the negative 1, while the 27 in the base of the second log can be rewritten as 3 to the third. Then you can move the exponent 3 on the base as an exponent of 1/3 on the argument. Now that they have a common base, you can combine them using the product property. However, before you can combine them, you must move the coefficients on the log back as exponents of the arguments. Next, rewrite 9 to the power of 2/3 so that it has a base of 3. This will give you 3 to the power of 4/3. Now you can add the exponents together to get 3 to the power of negative 8/3 as your argument, so that you are only left with log base 3 of 3 to the negative 8/3. Therefore, the log base 3 and the 3 in the argument will cancel out using an inverse property, leaving the answer as negative 8/3.